Math!
Hello, this is Mr. Regener, and today on the Aftermath, we're focused on focus. Specifically, we're going to take a look at focus for week 2, day 2. I'm hoping that as I run through the focus questions, it's going to help you as you watch this video, because you're going to be able to review exactly how to complete each problem and how to read each problem, how to set them up, etc. That way you're going to be able to do the very best you can on your quiz coming up for day 4. So let's first start off by reading question number 1. Mr. Edwards is making sandwiches. He has 4 pounds of cheese. He puts 1/8 pound of cheese in each sandwich. What is the total number of sandwiches Mr. Edwards made using all 4 pounds of cheese? Now, occasionally I'm going to give you a few tips that could be universally used for all of our focus activities, or really just all story problems in general. One of those tips that I'm going to give you right now in a multiple choice question is don't look at the options. Instead, try to solve the problem on your own first and see if your solution matches up with one of the answers. That's just one trick that I'd recommend that you try. And sometimes that can sort of avoid you going down the wrong path because you think one of the answers is the answer. So let's try that method out today. Another tip that I'm going to give you is visualizing what you're seeing in those story problems. So we have this story problem about Mr. Edwards and cheese, of course. That maybe doesn't really mean too much to me, but when I visualize, think about that. If I am Mr. Edwards and I have cheese and I want to make sandwiches, now I'm starting to get that visual image, which I think can be helpful in solving these problems. So let's take a look at it here on my paper. So one thing that I can do on my paper if I'm trying to visualize this all out is to literally draw out what the story problem tells me. And here Mr. Edwards has 4 pounds of cheese. So I'm going to draw out 4 pounds of cheese. And I'm just picturing like a block of cheese. There's my block of cheese. So this is 4 pounds of cheese. And again, this might be Swiss or American. It really doesn't matter. We just know that it's cheese. I know that if this is 4 pounds of cheese, I can sort of visualize and break this up to show what 1 pound of cheese would be. All right, so if I split this right here in the middle, that would be 2 pounds of cheese. So let me do that. So that would be 2 slices, I guess, of cheese, right? So this would be 2 pounds, and that would be 2 pounds. I can break that up again, just like that. Now I have 1 pound, 1 pound, 1 pound, 1 pound. So in other words, this is 1 pound, 1 pound, 1 pound, and 1 pound of cheese. All right, so 4 pounds total with 4 individual pounds being shown. If we know Mr. Edwards is going to use 1/8 of a pound of cheese to make his sandwiches, we know we could take this 1 pound block of cheese, or 1 pound slice, I guess, and divide that up into 8ths. So again, I'm going to cut it in half. Right about there is half. Cut that half in half, and then cut that half in half. Let's do that on the other side here. All right, we're getting a little tricky here because I maybe should have drew this a little bit bigger, but that basically is 8 slices, so 1/8 of 1 pound. And I could do that very same thing for all these parts over here. So I like to cut it in half, cut the half in half, and then cut the half of the half in half. As much sense as that makes, right? So there we have it. So now there's a kind of a long way of doing this, and that's just to count up how many 1/8 pieces I have. So I know I have 1, 2, 3, 4, 5, 6, 7, 8 in my 1 pound. That means I'm going to have 8 in my other pound, 8 in my other pound, and 8 in my other pound. In other words, I can make 8 sandwiches from each of these pounds. Knowing that, I can make 8 with 1 pound, I can make 8 with another pound, 8 with another pound, 8 with another pound, and I'm basically just adding that up. So it's 8 plus 8 plus 8 plus 8. You don't really need a calculator to figure that out. I'm hoping you know that would be 32 sandwiches. Now, if we think about this, when I was slicing up the cheese here with my pen, I was really just dividing it up, right? I took that 4-pound block and cut it into 4 individual pieces to create 1 pound, 1 pound, 1 pound, 1 pound. Then I took each 1 pound piece and cut it up to make 1/8 pieces. What I'm really doing by cutting that up, another way of saying that is that I'm dividing it up. And so if you think about that, we really are doing a division problem. So what I just showed you is maybe the long way of doing it. It's the way of visualizing it and showing how we are dividing that all up. But we can actually divide just with our mathematical skills. So let me go ahead and write this down here as a math problem on my paper just below where I was working. So we have 4 pounds of cheese divided by 1/8. Now, one thing that we are going to get used to is the idea of dividing fractions. If we know we have 4 pounds of cheese, think to yourself about what fraction that really is. So I'm just going to rewrite this as the same problem. 4 is really 4 over 1. Okay, 4 over 1 is an improper fraction. 4 is higher than 1, it's bigger than 1, it's larger than 1. And if we were to figure that out, we know that 1 would go into 4 times. That makes the whole number 4. So we'll make that an improper fraction just so that we're playing with the same types of things here, 2 fractions. So we have 1 fraction divided by another fraction. Whenever that is the case, we want to use the method that I call KCF. In other words, keep, change, flip. Okay, that's something that if you are not aware of it, I want you to be. Keep, change, flip. That makes this whole thing super, super easy. So let's check it out here. Scooch my paper down a bit. I'm going to keep my first fraction the same, 4 over 1. That's the keep, the K. I'm going to change my division sign into a multiplication sign. Then I'll flip the F, the last fraction. In other words, I'm using the reciprocal of that last fraction. So now my division problem, where maybe I was confused before, after applying KCF or keep, change, flip, now I have a simple multiplication problem. 4 over 1 times 8 over 1. Now, we know, I'm hoping, how to solve a multiplication problem involving fractions. It's pretty simple. We're just going to multiply straight across. So 4 times 8 equals 32. Put my fraction bar, 1 times 1 equals 1. Once again, we have an improper fraction, 32 over 1. 32 over 1 is really equal to the whole number, 32. So my answer here is 32 sandwiches, which, by the way, is the same answer we came up with by doing it the long way. So whether we are dividing it up visually here in my picture, or whether we're doing the math, we're coming up with the same answer. Coincidentally, this is a great way to check your work. All right, so if you solve it the math way and you want to try it out the visual way, just to double check yourself, or perhaps you're trying it out the visual way and you want to try it out the math way as well, using 2 methods is always a great way just to make sure that you're 100% accurate, especially when it counts for the quiz. So there you have it, that's number 1. Let's go ahead and take a look at number 2. As you look at number 2 and 3 on our activities are always going to be constructed response. So it requires a little bit of extra work for us because we don't have the multiple choice options. But hey, we're cool with that. We can answer these questions no problem. Let's go ahead and dive into the problem. It says, an art teacher has 7/8 gallon of paint to pour into containers. If he poured 1/3 gallon of paint into each container until he ran out of paint, how many containers had paint in them, including the one that was partially filled? Now, always a good idea to read the problem for sure. Not a bad idea either to read it twice, 3 times. We want to completely understand what that question is asking us before we just jump in and start solving. One of the big things you're going to notice is that phrasing at the end. It says including the one that is partially filled. So that gives us a big clue that if we have extra paint left over, that's partially filling a container, our answer is going to be a whole number. It's not going to be a mixed number, because if a container is partially filled, we include that as one whole container that's needed. Let's go ahead and visualize this. I'll try to draw it out here on my paper. So here it is. I've got a fresh, clean piece of paper out on my desk. And you'll probably just be able to continue on with notebook paper. For my purposes, though, it's probably easier to look at a fresh sheet of paper for number 2. All right, so it says that we have 7/8 gallon of paint. So there's 7/8 gallon of paint. The art teacher wants to pour them into 1/3 gallons containers. So I don't know how many containers I'm going to need. At this point, I'm just going to draw some out. Some we may use, some we may not. And if I need more, I can always draw more. So I'm going to say this is 1/3 gallon. This is 1/3 gallon. This is 1/3 gallon. And surprise, this one is 1/3 gallon as well. So, picture it for a minute that I have one big container up here. Maybe this is my big giant container up here that's 7/8 gallon. I'm going to pour paint into all these smaller containers and then see where I'm at, see how many containers I need. So one thing that we may want to think of, if I have 7/8 gallon and I'm pouring it in here and it's going to fill up 1/3, think about what that's doing to my 7/8. It's subtracting or taking away 1/3. So let's do that as a math problem. We have 7/8 gallon minus 1/3 gallon. Okay? And anybody who's been around fractions before knows that we can't just take 7/8 minus 1/3. No, no, no. They don't play nice. They don't play nice like that. Instead, we have to make sure that our bottom numbers are the same before we subtract. All right, so we have to have common denominators. Now, as I look at this, I could take 3 and double it. That becomes 6, but that's not 8. If I triple it, that's 9, and that's not 8. Okay, so I know that I have to do something with 8 and I have to do something with 3 because they need to play nice. They have to have the same denominator. One thing that's like a guarantee every time is I can just multiply these two numbers by each other, and then I'm going to get a common denominator. Now, sometimes we can find a common denominator without having to multiply them by each other, but in this case, it's going to be easiest to just think of it that way. So watch what I do here. I'm going to take my 8, and I'm going to say real small here, 8 times 3. If I do something to the bottom, I have to do it to the top as well. So I'll say 7 times 3. Over on the other side, I have 3 times 8. And again, if I do it on the bottom, I have to do it on the top. Okay, so now I have some real quick multiplication to do. So 8 times 3, that's going to give me 24. That's my new denominator. Up top, I have 7 times 3. That's going to give me 21. I'll keep my subtraction there. 3 times 8, that gives me 24. And look at my matching denominators. I'm feeling good about this. And then 1 times 8 gives me 8. So I have 21 24ths minus 8 over 24, or 8 24ths. Okay, so what I'm doing here is I'm taking this, which is really 21 24ths, or 7/8. It's the same thing. Those are called equivalent fractions. If I dump out 1/3 gallons, or 8 24ths, this is going to tell me how much I have left over. So if I have 24 and 24 on the bottom, my denominator stays the same in subtraction. I really just worry about the top numbers, my numerators. So 21 minus 8, that's going to give me 13. So I have 13 24ths left over. So let's pretend for a minute that I filled in my first container with that 8 24ths. Okay, so now I have 13 24ths left over from my big giant container up here of 7/8 gallon. So once again, I can take my 13 24ths, I'm going to dump that into my next container. So that's like we're subtracting 1/3. And remember, 1/3 is the same as 8 24ths. So I did that conversion already. I don't need to do it again. Okay, I can just take 13 24ths. Okay, that's what I had left over. And I'm going to subtract 8 24ths. Okay, because that's the same as 1/3. Again, we need to work, I guess, smarter, not harder. If we already did the math up here, we can just reuse that same math down here. So 13/24 minus 8/24, we've got a little bit of a subtraction to do. So 24 and 24 on the bottom, that stays the same. So our denominator is still 24. 13 minus 8 on the top, that's going to give me 5. So I have 5/24 left over. So again, let's pretend I filled up now this second container, and all that's left over from this big giant vat up here is going to be 5/24 down here. Now, 5/24 being poured into this. Let's do that math. Scooch down here so we can see it on the video. So I have 5/24. I'm going to subtract 8/24, right? Because that's 1/3. And look what's going to happen. 8/24 is bigger than 5/24. So what that tells me is when I pour it into this last container, I'm not going to fill it up all the way. It might be like filled up, a little ways there, but it's not going to make it filled up all the way. It's going to be like 3/24 left over. Okay, so think back to the wording on that original problem when I read it to you. It said, how many containers do we need, including the container that's partially filled? So let's go back to our drawing board here. We have one container all the way filled, two containers all the way filled, and the third container partially filled. So how many containers do we have? We have 1, 2, and 3 containers. So my answer is 3 containers. 3 containers are needed for 7/8 gallon of paint. Okay, I drew this out, by the way, with a 4th container. Notice we didn't use that 4th container. Okay, I wasn't sure at the beginning how many I would need. I put it on there just for fun, just in case we needed it. Turns out we only needed 3. 2 of them are all the way filled, 1 is partially filled, but that means we need 3 whole containers in order to pour that paint in there. Okay, so that's how we solved number 2. We're doing a great job, and let's keep on going and take a look at number 3. So number 3, again, a constructed response question. Let's take a look at it. It says, Jamal has 1/3 yard of kite string. Carmen has 7/10 yard of kite string. How much longer in yards is Carmen's kite string than Jamal's kite string? And then in parentheses, answer must be in simplest form. All right, so we've got ourselves more fractions to deal with. Think about it though, visualize kite string. Jamal has 1/3 yard, Carmen has 7/10 yard. What we're essentially doing is comparing the kite string between Jamal and Carmen. And as a special tip here, we're given a huge bonus tip in the question because it says how much longer is Carmen's string than Jamal's. So right off the bat, we know that Carmen's string is going to be longer than Jamal's string. Big tip for us. Let's go ahead and take a look at it here on paper. All right, so again, I'm a visual person. I'm going to just go ahead and draw out 2 kite strings. One of them is a bit longer than the other. We know the longer one already is going to be Carmen's. I'm just going to mark that with a K. I'm going to mark the other one with a J because that's Jamal's. Now Jamal's is 1/3 yard. And Carmen's is 7/10 yard. Okay? So we want to figure out how much longer this is. So if I figure out how much 1/3 would be based on 7/10 and how much is left over, that's my answer. This, again, similar to number 2, is a subtraction problem. So we know that 7/10 is the longest one. So if I'm making a subtraction problem and setting it up, I'm going to have 7/10 minus 1/3. That's going to give me, as I look at this, whatever this amount would be right here, because that's the extra, the part that's longer than Jamal's. And so we're going to figure out how long that would be. So let's set it up. Subtraction problem. 7/10 minus 1/3. Notice my labels are important, but I don't put them into my question down here. The reason for that is because I'm worried about the math. I can put the label back on later. Okay? So just like before, these numbers don't play well together. I want to find the common denominator. Here I have 10. Here I have 3. If I think about 3, I can go to 3, 6, 9, 12. Ooh, it's not going to work out so well with 10. So again, both numbers have to change. Just like before, I'm going to advise us that we look at maybe multiplying 10 times 3 and 3 times 10. If you think about it, 30 is going to be a number that we can probably use. So let's do that. I'll take 10 times 3 and 3 times 10. But if I do something on the bottom, I have to do it on the top. What's done to the denominator is done to the numerator. So let's take 7 times 3, 1 times 10. Okay? Now let's roll with it. 10 times 3 is 30. There's my new denominator. 7 times 3, 21. Put our minus sign in. It is a subtraction problem. 3 times 10, 30. 1 times 10, 10. Okay, now that we're on the same playing field here, we both have 30s in our denominators, this is becoming a much simpler problem. So what is 21 minus 10? You're going to come up with 11. And it's 11 over 30 because our denominator stays the same. Now, the question had the parentheses there. It said, make sure your answer is in simplest terms. What that means is we have a fraction that is simplified as far as we can go. It can't be simplified anymore. As we take a look at our paper again, 11 thirtieths, can that be simplified down anymore? Think about it. I could cut 30 in half and it'd be 15, but I can't cut 11 in half. All right. In fact, as I think about this, more and more options, 11 is not going to be able to be cut down at all. Okay. That is in simplest terms. So I want to answer completely with a label. So my answer then, as a final answer, is 11 thirtieths yards. So was it Carmen's kite string is 11 thirtieths yards longer than Jamal's. Okay, and there is our answer for number 3. We are moving right through this. There's one more problem left, and of course we always want to prepare for our computation as well. But let's take a look right now at number 4. Number 4 is a multiple answer question. What that means is there's going to be more than one correct answer, multiple answers. We want to find all of the correct answers. Okay, in doing so, we're going to find out that some of the options that are given to us are not correct. Let's read the question and get into it. The ticket prices to a play are $12 for teachers and $7 for students. A group of 83 students and 9 teachers are going to see the play. Choose all the statements that are true. Now here, and remember back on number 1, I suggested let's not pay attention to the options. For number 4, I'm changing that up because now it's multiple answer. It's not a bad idea to look at your options first, kind of know what the possibilities are. Okay, so for this one, it says A, the cost for the students is $84. B, the cost for the students is $996. C, the cost for the teachers is $84. D, the total cost for the teachers is $108. Or E, the total cost for the group is $689. So just in looking at those options, we know between A and B, those are the costs for the students. If A is right, we can say B is wrong. Same thing for C and D, because those are both the costs for teachers. If C is right, then D is definitely not right. Okay? So we want to think, logically, be smart about our answers, and knowing that going in, if we find one answer, we can possibly eliminate another answer. So let's get to work here on our paper. Again, I'm bringing up a fresh sheet of paper. Not that you have to do that every time. You're probably just working through these on your notebook paper, but this is really just for the video purposes. So let's think about this. Ticket prices are $12 for teachers. So teachers, I'm going to mark as T, are paying $12. Okay? And then students, I'll mark with an S, they're paying $7. Okay? If we know this going in, there's 83 students and 9 teachers. Okay, so 83 students and 9 teachers. So let's figure out first how much it would cost for the teachers. If there's 9 teachers, it costs $12 for each teacher. What type of math are we going to be doing? Just kidding. I can't hear you. It's a video, but I'm assuming that you might have said one of two things, addition or multiplication. If you said addition, you're not wrong. However, you're somebody that's going to take much longer in solving this. We could take 12 plus 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 12. That's 9 times. But it's much, much simpler to say 12 times 9. Now I say 12 because it is $12 even. If it were $12.50, I might have to put that decimal in there, but I know it's just $12 even. Okay, so just practicing some basic mathematics here in multiplication. 9 times 2 is going to give me 18. I put the 8 down here, and my 1 carries up top. Now I have 9 times 1, that's 9, plus that 1, that's going to be 10. So I put my 1, 0. That means for the teachers, it costs $108 to go to the play. Oops, I should say for the teachers. Now, if I look back at my multiple choice options for A and B, A said the cost for for C and D, if we were talking teachers, the cost for teachers is $84, or the cost for teachers is $108. Again, I just worked this out, so I know the cost for the teachers is $108. That being said, I know then that D is an answer. I also know then that C is not an answer. So I know this work right here tells me that D is correct. Let's do the same type of math, but now for the students. So there's 83 students that cost $7 each. That means we're going to take $83 times, 83 students times $7. Now notice real quick here, up here I had 12 on top, that was the cost, and 9 on the bottom, that was the amount of teachers. Now I have the amount of students on top and the cost on the bottom. That's because in multiplication, the order doesn't really matter. I'm putting the larger numbers on top because it's going to make more sense for me as I do the math. I could switch them if I want to because the order doesn't matter. I like to have the larger numbers on top. Let's go ahead and do some math. So we have 7 times 3, that's going to give me 21. So I'll put my 2 up top. I have 7 times 8, that's going to give me 56, plus 2, that gives me 58. Okay, so this math then tells me that it costs $581 for the students. It costs $7 for each student. There's 83 of them. Now, as I look at my multiple choice options here, or multiple answer options, I should say, A says the cost for students is $84. B says the cost for students is $996. Let's take a look at this again because I found out it was $581. This is what I like to call a trick question, kind of, because they're giving us 2 options and neither one is correct. It's not costing $84. It's not costing $996. Therefore, I know that A and B are not correct. My math says those are not correct. Let's look at option D, though. It says the total cost for the group is $689. Now, there's still a chance that E could be correct. So let's take a look and see. So if it costs $581 for the students and $108 for the teachers, if we add these things together, that's going to give us the total cost for the trip. So let's do some addition. We have 8 plus 1, that gives me 9. 8 plus 0, that gives me 8. 5 plus 1, that gives me 6. That's $689 total for teachers and students. Okay, hoping that showed up in the video, by the way. All right, so if I look at option E, it says the total cost for the group is $689. It just so happens that's what I figured out here on my paper. So my option E would be correct. So as I look at this, option A, nope. B, nope. C, nope. D, yes. E, yes. I have 2 options there that are correct. So my correct answers are E and D, or D and E. All right, because I have 2 answers that worked out mathematically. Now, this was focus for week 2, day 2. Your quiz for week 2 will have questions that look mighty similar to these questions. So it's always a good idea to maybe not memorize these answers, but know how we would get these answers on your quiz so you can do your best to get your best score. All right, until next time, this is Mr. Regener, and this is the Aftermath.
Math, aftermath, it's the aftermath. Aftermath, it's the aftermath. Math class is fun, but when it's done, stay in the zone. On your own, it's math review, made just for you. Take a video wherever you go. Aftermath, it's the aftermath. Aftermath, it's the aftermath. Oh yeah.